Hey guys, what's up everyone? Welcome or welcome back again to another tutorial video from the AB3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to be looking at the trigonometrical ratios. In our last two previous uploads, you would have seen where I have uploaded a video explaining the Pythagorean theorem, and I had also done a video on some examples using the Pythagorean theorem. Definitely check those videos out. A link will be in the description below, and also you can find the link in the top right hand corner in the cards for you, and you should definitely go ahead and check that video out. All right, now if you're a student that is currently watching this tutorial, I mainly aim to help the CSEC, SEA, CCSLC, EDEXCEL students, CAPE, AdMath, and college math students with a variety of concepts that are sometimes posing a challenge to them. So of course this is one of the topics that I've been getting a lot of requests about as it relates to the trigonometrical ratios. I'm going to take a time out here to just kind of go through the whole entire concept behind it, what are the ratios, how they are used, and we're definitely going to try to gain some sort of platform or some sort of knowledge as it relates to becoming a little bit more effective with this topic. Now, if this is the first time here on the channel, to be consistently notified as it relates to content, smash the subscribe button below, turn on the post notification bell, and if you're getting any sort of value, please be sure to smash the like button. Leave me a comment down below, leave your questions and suggestions in the comment section down below. Now let's get right into the video. Now we are talking about the trigonometrical ratios. What are the ratios? We're not going to be going through where they are, how they are derived. I'm just going to go ahead and tell you what they are. I'm going to do some application questions and let's see how we go about this. Now on screen here, you can see some information where we're seeing that the trigonometric ratios are used to find the length of an unknown side. But in addition to finding a side, we are also capable of using it to find the size of an unknown angle. All right, so it does two things for us here, and specifically you can see that the ratios are used in a right angled triangle. All right, so that's what we use it for. We use it to help us to find the length of a side, and we also use it to find the length of the size of an angle. Now in this video we're just going to be focusing on finding the length of the side, but in another upload I'm going to show you how you can use it to find the size of an angle. Now there are actually 6 trig ratios, but at this level, the CSEC level, we are only using 3 of the 6. Now it says here the first thing that we have to actually start talking about as it relates to really comprehending the trig ratios or trig in general is ensuring that we have prior knowledge of the different types of triangle. All right, now we have the isosceles triangle, and we have the scalene triangle, we have the equilateral triangle, and the one that we're actually looking at right now is the right angled triangle. So that's our primary focus. Now the right angle triangle, as I had discussed earlier in my previous tutorial, a link is in the description. You definitely want to be a little bit equipped with using the Pythagorean theorem before you're actually watching this video, so ensure that you are already familiar with the Pythagorean theorem. Now here, let's discuss the right angle triangle once more. We had said earlier that we name angles with capital letters, and the angles are located at the vertex of the diagram. So you'd obviously find that angle A would be here, and angle B would be here, and this here would be angle C. Now this diagram is kind of highlighting the whole Pythagorean theorem application. Now just to make certain that if there's anybody here who's watching this video and you haven't seen the Pythagorean theorem application, we had said that the 90-degree angle that is here, it usually points or looks at the hypotenuse. And generally, I tend to use the letter C to represent my hypotenuse. All right. Now, A and B are going to be the sides, the length of the sides of the legs. That is when we were using Pythagorean theorem. We would call this vertical side here and this side here legs. Now in this video, we're going to give the legs a name. But in a moment, I'm going to go about explaining that to you. So here, we name the hypotenuse C. So according to Pythagorean theorem, it's going to be the square on the hypotenuse is going to be equal to the square or the sum of the squares on the legs. So this would have been the formula for Pythagorean theorem. So we are already equipped with that. Now, as mentioned before, that these sides prior to this video, we would have called these sides legs. But now we are going to be introducing to the right angle triangle some angles. And these angles that are right here and right here, we refer to these angles as being reference angles. All right, so these are called reference angles. Now, the position of these angles is going to determine one specific side of the triangle. And depending on the angle that is given in the question, or it depends on the angle that is being used in the question, or it depends on the angle that you choose to use, depending on how much information is in the diagram, then that angle was always going to tell you where the opposite side is. Now, let us just say, for argument's sake, that the green angle here is our reference angle. Then this angle is always going to be steering at the side that we call the opposite side. However, if this is our reference angle, if the blue angle here is our reference angle, then the opposite side is going to be in front of it here. And that would be our opposite side here. Okay, so basically we're saying that the opposite side and the adjacent side is interchangeable, meaning that they're going to there's not a set side that we can assign to be the opposite or the adjacent. It all comes down back to what is called the reference angle. Now let's head over here. Now prior, as I mentioned before, that one side that we know remains constant is the hypotenuse. The hypotenuse is the side that is always in front of the 90-degree angle. Now here you can see I have some labels here. Beta, that is a Greek symbol used to represent an angle. And here we have alpha, another type of Greek symbol that we use to represent an unknown angle. Now remember, in the Pythagorean theorem, this would have been called the leg. This would have been called the leg. Or we can refer to this as being the perpendicular side and this being the base side. So that is how we do it. But just now you can see that if alpha is our reference angle, then you'll find that alpha will give us this side to be the opposite. And then, of course, because alpha has directed us to the opposite, then this becomes the adjacent side. Now, on a switch, or on the other hand, if beta was our angle, then beta would pretty much direct us to where the opposite side is going to be. And then, of course, the other side automatically would become the adjacent side. All right, so hopefully you guys got the whole idea behind which side is the opposite and which side is the adjacent. So hopefully that little recap there can give you a little gist of what went on in the previous tutorials. But if you want to get a little bit more in depth and you really want to get involved in the calculations, check the video out. A link is in the description box below. Now we're going to get into what this video is primarily about, and it's about the application of the trig ratios. Now before we actually get into what are the trig ratios, the ability for us to label the sides are going to be key. Now, I've been reiterating this for the past couple of minutes or for the past 10 minutes, but it's very, very important that this aspect of application is key. You must understand, you must understand that this side here is the hypotenuse. And of course, notice here that I have an angle marked by theta. And theta, you can see, obviously sends us to the side where the opposite is, and the other side is the adjacent. Now, what we call the other two sides will change on depending on the angle we're working with, as I had mentioned before. So if we are given or need to work out this angle, we label the other sides like as I've instructed here. The opposite facing the angle, the adjacent facing the other side. The hypotenuse is always the one that is in front of the 90-degree angle. Alright, now here are the ratios. The ratios are sine, cosine, and tangent. Sine, cosine, and tangent. Now we abbreviate them as SIN, cosine, COS, tangent, TAN. And it's always the sine, the cosine, or the tangent of the angle or the reference angle. Now, for abbreviation purposes or we use a mnemonic to help us to remember the trig ratios. Some examinations or some curriculum will provide you with the formula, while some curriculum may not provide you with the formula. So we use the mnemonic Socatoa to help us. So the so would explain to us the formula setup for sine. The ka would explain the formula setup for cosine, and the toa would set us up for the tangent ratio. And once again, here you can see that the hypotenuse is the side that faces the 90-degree angle. Theta points to the opposite side, and of course the other side is the adjacent side. All right, good. So those are the ratio. Sine of the angle is equal to the opposite side divided by the hypotenuse, and the cosine of the angle is equal to the adjacent side divided by the hypotenuse. The toa, tangent, theta is equal to the opposite side divided by the adjacent side. So make sure that you have those formulas pat down inside your head, or at least you can rely on the spelling of the mnemonic to help you remember what formula or what side connects with what side. Okay, now that's how we remember the ratio, Socatoa. All right, now there are many different ways that you find that people will use to remember the Socatoa. I just generally use the mnemonic Socatoa, but there are persons who will use the Socatoa Pyramid. All right, I won't be going through the use of the pyramid, but just as a quick intro, they're saying here that in order for you to use the Socatoa Pyramid, you are to cover the letter which is the unknown value. So if it's the opposite side, that's the unknown value, you'll get a chance to see what needs to be multiplied or what needs to be divided. Okay, so let's say, for example, I wanted to find the hypotenuse. Okay, let's say that I'm using the sine ratio and I needed to find the length of the hypotenuse. Then I would use my fingers to cover the h, and then clearly it would tell me that in order for me to get the hypotenuse, I would have to divide the opposite side by the sine of the angle, because O divided by the sine of the angle. Let's say that I wanted to find the angle using cos. Then I would cover the cos theta and that would have been the adjacent divided by the hypotenuse. But because I'm finding the angle, I'm going to have to find the inverse trig ratio. We're going to get into that into part 2. And if I wanted to find, let's say, the opposite side, and I happen to be using tan, then I would cover the opposite side, and you'll clearly see here that I would have to take the tan of the angle and multiply it by the adjacent side. Alright, so there's several different ways in which you can use to remember the trig ratios and its application. You have to choose the one that suits you best. Okay, alright, good. So we're going to move on next. Now, here is the most important part of the video. The most important part is we are exposed to 3 different formulas that can help us to solve a single math problem. How to, when, and which ratio should we use? How do I know when I get a diagram that I'm supposed to use the cos ratio, the tan ratio, or the sine ratio? It all boils down to 3 single steps. I don't even want to call them steps. I think I just want to call them a technique that I use to figure out how to and which ratio to use. But I feel like once you follow these 3 guidelines, steps, whatever it is that we want to call it, then you will find at all times, it works for me, that at all times you're never going to miss when it comes to selecting the correct ratio. So here are the steps. The first thing that you must do every time that you get a right angle triangle and you know that you're going to be using the trig ratio is that you must be able to identify the different sides of the right triangle, which means that as long as the orientation of the diagram changes, then you're always going to know which side is the opposite, which side is the adjacent, and which side is the hypotenuse. So you want to label those sides H, O, and A. Now, like in everything that we do, there must be something that is being required to find, and there must be something provided to you to help you find what you're looking for. So sometimes you may be required to find an angle, and there's other times that you may be required to find the length of a side. Okay, so it depends. And what must be given? You have to be given some sort of information. More than likely, if you're finding an angle in the right angle triangle, you are going to be provided with 2 sides. And if you're finding a side in a right angle triangle, then you must be provided with a side and an angle. So look out for those. And then once you've completed step 1 and step 2, right, then step 3 is where you'll see the ratio pop out at you. You're going to see it naturally. Let's have a look. So here we have a very simple diagram, and it says use trig ratios to solve for the variable. Now, please understand, for this particular question, you're being told to use the trig ratio, but in a general examination, you are going to be the one that would have to see the diagram and evaluate should or should I not use the Pythagorean theorem, or should I use a trig ratio. So this particular question here is kind of giving you a clue. They're kind of telling you that it is a trig ratio that you have to solve. Now, I do encourage all my students that I've taught and who I'm currently teaching that once presented with a right triangle, ensure that you eliminate the use of the Pythagorean theorem. So once you've eliminated the use of the Pythagorean theorem, then there's only one other set of formulas that can assist you, and that would have to be the trig ratio. Now, we are in fact looking for a side that is H. However, because we are not provided with 2 sides, then we cannot use the Pythagorean theorem. I've emphasized this in my previous tutorial, so you definitely need to check that out if you haven't already. Once you're going to be using the Pythagorean theorem, you need to have, or you need to be provided with 2 of the sides. Now, you haven't been provided with that information. You're only been provided with 15 centimeter or 15, whatever that represents, and we're being provided with an angle. So now let's apply the steps. The first thing, as I mentioned to you before, let's skip back to that here, is that we need to actually identify the different sides of the triangle. So we identify the sides. We know right away that the 90 degree tells me where the hypotenuse is. The 38 degrees, which is the reference angle, it directs me towards the what? Opposite side. And subsequently, the other side becomes the adjacent side. So once we have done that, then we now have to look at what is it that they're asking me to find. They are obviously asking me to find the variable h, which is being represented by the opposite side. And of course, they have provided me with 15, which is being represented by the hypotenuse. And I have the support of the angle because I need an angle in order to use the ratio. So now we have to ask ourselves the question. We are looking for the side that is being represented by the opposite side, and we are provided with a side that is being represented by the hypotenuse. So which of the ratio, according to Socatoa, involves the opposite side and the hypotenuse? Clearly, you can see that is the sine ratio that involves the opposite side and the hypotenuse simultaneously. So that sends us into our calculation phase. Now we did state earlier that the sine of the angle is equivalent to the opposite side divided by the hypotenuse. So we know that the sine of 38 degrees is going to be equal to the opposite side, which in this case we do not know. So we can call it the h as indicated on the diagram, and we're going to be dividing that here by the hypotenuse, which is 15. Now you should have your calculator at hand, and you need to also ensure that your calculator is in degree mode. So at the top of the calculator you should see a D. So you go ahead and you hit the sine function, you hit 38, and you'll find that the sine of 38 is 0.6156, and that's going to be equivalent to h divided by 15. Now 15 multiplied by 0.6156 will give us the answer for h. Now usually we find that once the unknown variable is at the top of the ratio, the shortcut is going to be that we multiply both values, or you cross multiply. So therefore we're going to find that h here is equal to 15 multiplied by 0.6156. So we go ahead, 15 multiplied by 0.6156, and we're going to find that our final answer here for the side being represented by h is 9.23. Alright, now you have a choice. The question will instruct us to round it off to a certain amount of decimal places. If not required, 1 or 2 decimal places is accepted for our solution here. So hopefully you guys got the understanding behind choosing the correct ratio and applying the ratio to the question. Ensure that you hit that like button if you're getting some value already. Let's move on to another example. Now in this example here that we're looking at the fact that we're looking for 2 letters, and this is a very interesting question. And the reason why this question is so interesting is that usually when you're using the ratio, we tend to always be supported with a side and an angle. And now we are looking for 2 sides. Now there's a couple of ways, and this is going to be a very interesting question because it's going to bring out which decision is best. What do you prefer? Do you prefer using the ratio, or is there a possibility where I can find the is there a possibility where I can use the Pythagorean theorem? it's all about decision here. Now let's get into it. Naturally, I'm going to want to find x first, but because we have enough information to support us in finding y, you can find y or x first. But I'm just going to go right ahead and find x first. Now, can I use the Pythagorean theorem? That's the important question. We cannot use the Pythagorean theorem, at least not yet, because we are only supported with a single side and we are supported with an angle. And normally that's the indicator to let you know that the diagram is hinting at us that the trig ratio or one of the trig ratios is going to be to our aid. So here we go. If we have confirmed that the trig ratio is going to be our application, then we begin to apply the steps as instructed earlier. This 7 is being represented at the hypotenuse, and the x that we're looking for, obviously because the y is in front of the 36, then the y is being represented by the opposite side. And so the x that we're looking for is being represented by the adjacent side. Yes? So therefore, if that is the case, then we're looking for a and we are provided with h. So we're looking for a and we are given and provided with h. According to Socatoa, then we are going to find that the car is the ratio that's going to come into play, because that ratio deals with the adjacent and the hypotenuse simultaneously. So we go right ahead and we proceed. We write the fact that cosine theta, okay, so cosine theta is equal to, let me just give this a little brighter. So cosine theta is equal to the adjacent side divided by the hypotenuse. So the cosine of the angle, which is 36, is equal to the adjacent side, which is being represented by x, over the hypotenuse side, which again you can see here is represented by 7. So ensure that you have your calculator at hand. We're going to find the cos of 36 degrees, and that's going to be 0.809, and that's going to be equivalent to x divided by 7. So if we have that, then you'll find that just like before, the unknown is at the top, the unknown variable is at the top. So x is going to be equivalent to 7 multiplied by 0.809. X here is going to be equal to, let's multiply that here, 7 multiplied by 0.809, and that is going to be equivalent to 5.7 rounded off to 1 decimal place. So this side here is equal to 5.7. I strongly recommend, even though we are doing not such an advanced question, I strongly recommend that every time that you find an answer, insert the answer on the diagram. All right, for future purposes, when you're doing more advanced trig questions, if you're not capable of visualizing the diagram mentally, then sometimes putting the information on the diagram is going to give the diagram a little bit more life in terms of the availability of information. So that should help. Now here, we're just going to be looking at finding y. Now, once again, we have choices here. Now, we have already labeled the sides. None of the sides are going to change because the angle, the reference angle, has not changed. So now because you have the 7 here and you have the 5.7, we are listed with 2 choices here. We have a choice in terms of using the tangent ratio. Why can we use the tangent ratio? Let's have a look. We can use the tangent ratio because this side that we have now attained becomes our adjacent side, and we are looking for the opposite side. So the ratio that would involve the opposite side and the adjacent side would have been tangent ratio. But we are still capable of using the sine ratio because we are provided with the hypotenuse and we are still looking for the opposite side. So let me know in the comment section what's the result when you use the tangent ratio. All right, I'm actually just going to use the sine ratio because I am sure it could be a case where maybe you calculated incorrectly and the answer that you got here could have misled you. I don't expect you to get it incorrect, but if you do, then it might mislead you to getting the other problems incorrect. I strongly recommend that you use values and you use ratios involving values that were provided to you. That's just a safer route, right? Just to prevent you from making that odd error. So I do recommend that you use values that are provided to you by the question. So I'm just going to be using the sine ratio just for that purpose because I was provided with the 7 and I'm now being asked to find y, which is represented by the opposite side. So I know that O and H is sine, that is SOH. So here the sine theta is equal to the opposite side divided by the hype. And you're going to find here that the sine of 36 is equal to the opposite side, which is y, over the hypotenuse side, which is 7. So if you go here on our calculator, we're going to find the sine of 36. We get an answer of 0.5877, and that's going to be equal to y over 7. Again, the unknown is at the top, so we cross multiply. So y is going to be equal to 0.5877 multiplied by 7. And we get an answer that y is equal to 4.11. Okay, and that is going to be the length of y here. Now I want you guys to take the time out, pause the video, and I want you to use the tangent ratio and apply the steps that I showed you and leave it in the comment section. Let me know if you got the correct answer using the tangent ratio. All right, so hopefully you guys get that part down and you're a little bit better at the application of the trig ratio. All right, now that brings us to the end of this particular introduction video to the trig ratios. In future upcoming tutorials, I'm going to have a video with a bunch of questions using the trig ratio application. Not only very simple examples, but examples that are a little bit more advanced. Now I have a couple of videos coming out, so you definitely want to smash the subscribe button below and turn the bell on, because once you do and I post, you will be notified and you can watch these tutorials at your disposal or your convenience. All right, so do take care until next time. My name is Akin, your math instructor. Continue practicing and you will improve and become a better math student. Take care.